Through the rest of this lesson, we are going to examine precipitation, how precipitation is formed, the different types of precipitation, their durations, intensities, and the associated cloud types. First of all, how is precipitation produced? Well, we need cloud condensation nuclei, but these are usually fairly abundant. Cloud is made up of water droplets, ice particles, or both. The fall speed of these is negligible. Only by growth can precipitation be produced. Look at the respective sizes of cloud droplets, drizzle, and raindrops in this diagram. There are three main ways of growing cloud droplets into precipitation. These are condensation, coalescence, and through the Bergeron process. We shall look at these in turn, plus two additional concepts called accretion and amalgamation. Condensation is the least important here. The process of converting water vapour to water droplets produces only very small droplets, enough to give slight drizzle. But small droplets often evaporate before reaching the ground. We need to look at other mechanisms for producing precipitation of significant quantity and intensity. Within a cloud, droplets collide fairly frequently, especially when they have different fall speeds and when there is turbulent motion. Occasionally, these collisions cause droplets to join and form a larger droplet. These will eventually fall under their increased weight. This process is called coalescence. The final mechanism for producing rain is the most efficient. It is called the Bergeron process. This is quite complex, but essentially involves water vapour being sublimated straight into ice crystals. If there are also water droplets present, then the air surrounding them becomes less than saturated, which causes the water droplets to evaporate into water vapour. This water vapour rapidly sublimates onto the growing ice crystals. Once ice crystals are created, they have a relatively large fall speed, and hence drop out towards the ground quickly. They will grow further by accretion. This is when any water droplets collide with the ice crystals and freeze on contact. If they start to melt, they become sticky. They can then amalgamate into large clusters of ice crystals, that is, snow. The ideas we have shown here are fairly simple ones. What happens in clouds to produce precipitation is complex. The Bergeron concept has a weakness when the temperature of the whole cloud is positive, in other words, above 0 degrees. Growth by other means, such as coalescence, will then be more important. As we know from our own experience, there are many different types or forms of precipitation: rain, hail, snow, etc., and these sometimes fall steadily or sharply as a shower. In fact, we label precipitation as being showery or dynamic. But what does this actually mean? The nature of precipitation often changes as it falls to earth. For example, in colder weather, rain at the ground quite often starts off as snow within the cloud. The form of the precipitation at the ground is dependent upon the temperature of the lowest few hundred feet of the atmosphere, just before it reaches the ground. Showers fall from convective or heaped cloud. They can be of rain, snow, or hail. This is the symbol for a shower. Here are the symbols and codes for each that we will encounter in aviation meteorology. Rain showers, or SHRA, have these symbols. Snow showers, or SHSN, are represented like this. SHGR are showers of hail, and SHGS, small hail, hail with a diameter of less than 5 millimeters. These are coded like this. Showers develop in unstable atmospheric conditions from large cumulus clouds and cumulonimbus clouds. These clouds involve large updrafts of air within them, helping to support large droplets of precipitation. Hence, showers of rain tend to consist of large rain droplets. The convective cell drifting over the ground means the shower will have a relatively sharp onset and cessation, a feature of this type of precipitation. Within large cumulus and cumulonimbus clouds, the temperature is often sub-zero. Therefore, the precipitation will be of snow or hail at that level. But what happens around these clouds to give us different types of showers? Where the cloud temperature is sub-zero, the precipitation will be of snow. As we can see here, ice crystals join together to form snowflakes. Eventually, these become too large to be supported by the updrafts and fall to the ground. If the temperature stays low enough between the cloud and the ground, we have a snow shower. However, if the temperature is such that it melts, we simply get rain at ground level. Hail is formed when rain droplets are swept quickly to the top of the cloud, causing them to freeze. The small hailstone will then fall again, partially or completely melting, before being swept back upwards again. The hailstone will gather water by collision with other water droplets, again adding to the size. This may happen several times, adding more and more ice to the hailstone. Hailstones grow layer by layer and can visibly be seen in cross-section. By this mechanism, hail can become very large indeed, making it a hazard to aviation. Hailstones can measure in excess of 50 millimeters across and weigh up to 1 kilogram. To support a 1 kilogram hailstone, the updrafts must be very violent and therefore an area to avoid at all costs. Dynamic precipitation falls from layered cloud, as opposed to showers from convective cloud. It is characterized by its more gentle onset and cessation, and duration of several hours. Although note, this isn't always the case. This type of precipitation can be of drizzle, rain, snow, or sleet, or occasionally ice pellets, which are similar to hail but come from layered cloud. Here are the types of dynamic precipitation and the clouds we expect them to fall from. Drizzle falls from stratus cloud. Rain, sleet, snow, and ice pellets are all mainly produced from altostratus or nimbostratus clouds, and occasionally thick stratocumulus. Also on this table, we see the diameter of the individual particles that make up the various types of precipitation. So, for example, drizzle droplets have a diameter of between 0.2 and 0.5 millimeters, rain 0.5 to 5.5 millimeters, individual snow needles and ice pellets have a diameter of less than 5 millimeters. In layered cloud, the air currents are more gentle, and the processes that go into producing the dynamic precipitation are condensation, coalescence, and Bergeron. Although with snow, the aggregation of flakes plays a major part in the formation. Again, the form of the precipitation will largely depend upon the temperature of the air surrounding it. The final two things we need to look at about precipitation are the classifications of duration and intensity. As we have already stated, showers are of short duration but tend to be heavier in nature. Dynamic precipitation can be described as being intermittent. In other words, falling from time to time for usually less than 60 minutes. Or continuous, which is fairly self-explanatory and strictly lasts for 60 minutes or more at any one location. The intensity is described according to the following criteria. Slight rain, for example, is described as less than 0.5 millimeters per hour, whereas heavy rain is greater than 4 millimeters per hour. Notice that these figures relate to temperate latitudes only, because in the tropics, extremely heavy rainfall may be experienced, which is not covered here. Snowfall is represented in centimeters of accumulation per hour. From this lesson, we have seen that clouds are our signposts in the sky, letting us know what is happening in the atmosphere.